Year 10 and welcome to Straight Line Graphs Lesson 7. I'm going to start by giving you the answers to the quadratic curves from last lesson. So the way I'm going to do this is just to give you the tables, which you can see on the screen, which you should have filled out before you plotted them. So assuming you plotted the points correctly and you joined the points up with a nice smooth curve, you would have got the rest of the question correct. So could you pause the video and check your tables and mark your work? Okay, so moving on today, we're going to go back to straight line graphs and plotting those. And we're going to start to look at gradients and intercepts, and we're going to use those to plot these straight lines. So the equation you can see plotted on the screen here already is for y equals 2x add 3. So that's the graph and that's its equation. Now, if I substitute into the equation here, x is 0, I know this equation is telling me that I can work out y by multiplying x by 2 and then adding 3. So 2 lots of 0 add 3 will give me a y coordinate when x is 0 of 3. So that means that the point 0, 3 is lying on this line, and if we go back to the graph, you can see it right here. This is the point 0, 3. Now this point is called the y-intercept. It's where it crosses the y-axis. So we can see that the y-intercept is 0, 3 on the screen there. And we can also see that we've got a constant add 3 plus 3 on our equation here, because the y-intercept is always the point where x equals 0. So we're always going to be left with just the constant on the end. So we can read it off the graph where it crosses the y-axis, and we can also read it straight off the equation as well. Okay, so we know that the point 0, 3 lies on this line. What about when x is 1? Well, we're going to have 2 multiplied by 1 add 3, which will give us 2 plus 3, which is 5. And what about when x is 2? We'll have 2 times 2, which is 4, add 3, which is 7. And when x is 3, 2 times 3 is 6, add 3 is 9. And when x is 4, 2 times 4 is 8, add 3 is 11. So this is the table we would have created if we'd been using that first method for plotting this straight line. But what we can now see from the table is that as we increase our x value by 1, our y coordinate goes up by 2, and by 2 again, and by 2 again, and by 2 again. And this is just like a sequence that you would have done maybe back in year 9 where you found the nth term of a sequence. You know if a sequence goes up by 2 each time, then you're looking to multiply, in that case, n by 2. And this is exactly the same. So the fact we're multiplying x by 2 tells us that our y coordinate is going to go up by 2 every time. And I can now think about what that means for the graph. If I take the point 2, 7, which is in my table here, 2, 7, and I then increase my x coordinate to be 3, so I've increased my x coordinate 1, then my y coordinate becomes 9. So x goes up by 1, y goes up by 2, and I get the coordinate 3, 9. So this 2, that is the coefficient of my x term here, tells me that my y coordinate is going up by 2 every time, and it's also true for the graph. As my x coordinate goes up by 1, my y coordinate goes up by 2. And this is called the gradient, and it's how many we go up for every one along. So in this case, for every one along the x-axis, we go up 2 on the y-axis. Okay, so this is a good point to pause the video and get some notes written into your books. So the key points, y equals mx plus c is the general equation for a straight line. And the m part here, the coefficient of x, the number in front of the x, that is the gradient. And it's how many we go up for every one along. The plus c part here, that's the constant. That's the amount we're adding to the x term. And that will always tell us the y-intercept, where the line crosses the y-axis. So pause the video and make sure you've got this written down into your maths books. Okay, so we're now going to use what we know about the gradient in the intercept to plot our straight line really efficiently. But there's something we need to look at first before we do that, and that is, we looked at this line a moment ago, and this has got a positive gradient. It has a positive coefficient in front of our x, and that tells us for every one along we go up 2. But what about if we've got a negative coefficient in front of our x? What does that mean? Well, that means that we're going to slope downwards. And it means that for every one along, we go down 2 in this case. So you know that if you've got a negative number in front of your x, a negative coefficient, you're expecting the line to slope in the opposite direction. Okay, so how can we use this to plot our straight lines? So here we're being asked to plot the line y equals 3x plus 1 using the gradient and the intercept method. So first of all, we can look at this equation and we can read off the intercept, which is plus 1. That tells me that my line is going to cross the y-axis at plus 1. So the first thing I'm going to do is plot a point there. My gradient here is 3, and that tells me that for every 1 along the x-axis, I go up 3. So I'm going to go 1 along and up 1, 2, 3. And that's where my next point's going to be. And then along 1 and up 1, 2, 3. That's where my next point will be. Along 1, 1, 2, 3, and then along 1, 1, 2, 3. So I've got plenty of points plotted now. So all I need to do is to finish this off by joining those points up. It's really important we don't forget to draw the line on. I noticed on some people's work the other day that they had lovely plotted points, but they hadn't joined them up with a straight line. So don't forget that step. Okay, here's another one for you to have a go at. So could you pause the video? You're going to need to draw the set of axes, as you can see on the screen, into your books, and then see if you can use the gradient and the intercept method to plot this straight line. Okay, so our intercept here is plus 6. So I'm going to plot a point on the y-axis at plus 6. And the gradient is 4, so that means for every 1 along, I go up 1, 2, 3, 4. Along 1, up 1, 2, 3, 4. And that's actually enough for me to draw my line on, but if I want to, I can fill some in the other side. So I would have had a point right here, and then I would have had a point right here. And now I can join those up with a nice straight line. So have a look and see if you got that correct. Now, here's another example for you to have a go at. You can do this on the same axes as you drew out for the previous question. Just be careful here because the intercept now is -3. So pause the video and see if you can get this one plotted using the gradient and intercept method. Okay, so for this one, you should have plotted your intercept at -3 on the y-axis, and then it should have been along 1 up 5, along 1 up 5, along 1 up 5, and then you should have joined those up with a nice straight line. If your points don't sit on a straight line, then you have done something wrong and you need to go back and double check your working. Okay, this is an interesting one. We've got y equals 1/2 x add 2. So the intercept is no problem here. I know that I'm going to be crossing my y-axis at 2, but the gradient is 1/2, and that means for every one along, I'm only going to go up half. So I'd have a point around about here. So to go up a complete square, I'm going to need to go along 2 before I've gone up 1. So along 1, up a half, along 1, up another half. So I'd have a point plotted there. And then so on. So what I've got here is a line that is a lot shallower. It's not as steep as the others. I can join those up. Okay, here I've got another example, this time with a negative gradient. So my intercept is positive 12. So I'm going to plot a point at 12. And because the gradient is negative, that tells me for every one along, I'm going to go down 1, 2, 3. So this is where my next point will be. Along 1, down 1, 2, 3, and so on. And now I can join those up. And it's worth thinking beforehand, well, if this is negative, I'm expecting it to go the other way, and that way you can sort of catch yourself before you make a mistake. Okay, so on the same set of axes as you'd already drawn, you can pause the video and see if you can get this one plotted using the gradient and intercept method, taking note of the fact that this is a negative gradient. Okay, so you should have plotted a point at 10 because the intercept is positive 10. And then we're going along 1 and down 1, 2, 3, 4. And then along 1, down 1, 2, 3, 4, and so on. And then join that up with a nice straight line. So a word of warning here. You can see here that on the scales we've drawn on the axis, we've got 1 square is 1 unit on both axes. It's really important to understand that this is not about the number of squares you go along. It's about the scales on the axes. So if you take a look at the axes I've got here, well, I've got different scales, and on the y-axis, it's still 1 square is equal to 1 unit because I'm going up 1, 2, 3, 4, 5. But on the x-axis, that's different. My 1 is actually here, and that would be 2 squares. So I'm not going to go along 1 square and go up however many. I'm going to go along to 1 unit, and then go up however many I need to. So here I'm being asked to plot y equals 2x plus 2. The intercept is at plus 2. So I'm putting my dot at 2 on the y-axis, and then my gradient is 2. So I want to go along 1 on the x-axis, which is going to be 2 squares, and then up 2, which is also going to be 2 squares. So along 1 up 2, along 1 up 2, along 1 up 2, and along 1 up 2, and then join up. So it's really important to take note of the scales that you've got on your axes, because it's those that matter, not the squares. Okay, so your task for today, pause the video, draw out a coordinate grid from -15 to 15 on both axes, and then try and plot the following straight line graphs. You can do it all on the same grid using the gradient and intercept method. You can label each graph with its equation so that you know which one's which when you come to mark next lesson, and use different colours if you've got them, because it will just make it a little bit clearer. It's important you use the gradient and intercept method because that is what we're trying to learn here. So don't try and use a table and plotting it out that way, because otherwise you're not learning what you need to know about gradients and intercepts.